So you have already SQ3R this lesson in your notebooks. We have 2 learning goals today. One of them is, can I determine if a relation is a function? You need to make sure you understand what is a relation first of all, and then what makes a relation a function. So that's your first learning goal today. The second one is, I can find the domain and the range of a relation and a function. So if I say to you, what is the domain of this relation? You can do that. What is the range of this function, maybe? You can do that. Okay, so those are our two learning goals today. The top here is basically just kind of like an overview of what you should have already learned by doing your reading and the practicing you did ahead of time in your SQ3Rs. Somebody in your own words, tell me what you can say about relations and functions. Our first learning goal, being able to tell if a relation is a function and what's that all about? In your own words, not book words. You can use some of the words that came in the book. I know you can't make up your own words for everything, but relations, and then what's so special about functions? What is a relation then? Riley? Set of ordered pairs. Any set of ordered pairs that you have, you could say is a relation. Well, what's an ordered pair? What are they talking about when they say ordered pairs? What's that mean? What's an ordered pair look like? You did SQ3 on this lesson, right? Okay, what's an ordered pair look like? What notation are they written in? It would take a lot longer than I thought it would. Have you forgotten the question already?
Yeah.
What is an ordered pair? What does one look like? What's it made up of? It's got numbers in it. Okay, Avery's got it started. It's got numbers in it. Woo! What else? So do some random numbers. How many boys are in this class, and how many girls are in this class, and how many adults there are in this room, and they just throw a bunch of numbers together and say, here's the ordered pair? Whew. Are there any ordered pairs on that sheet in front of you? Anywhere? Can you see any ordered pairs written on that sheet in front of you? Anywhere. Just the top sheet. It's green, maybe that's throwing me off today. Are there any ordered pairs on there? And just give us a problem number or something that says, okay, yeah, here's some ordered pairs. Look around and be done with this.
Are ordered pairs like the little ones in the parentheses?
Yeah, oh, moving along. We got numbers and we've got parentheses. Yes. Benton.
There's some order ratios.
Pardon?
Ratios?
Like ratios? Well, there can be a ratio involved in an ordered pair, but that doesn't necessarily have to be. Lindsay. Number 2. Okay, everybody look at number 2. Number 2 is, number 2 look like ordered pairs?
Yeah.
Yeah. So there's how many numbers in an ordered pair? 2. Anybody know what relationship those 2 numbers have to each other in that ordered pair? In any ordered pair, you can say the first number is the what? Is the x value. And the second number is the y value. And those 2 are called coordinates. In other words, they can make a point on a coordinate plane. We can graph them on a coordinate plane. So an ordered pair is always written in parentheses. The 2 numbers are always separated by a comma. The first number is always the x value, and the other number, the second number, is always the. Whew. Yes, thank you you very much. Okay. So now that we know that a relation is a set of ordered pairs, and now we know what ordered pairs look like, what's the big deal? Okay, how many ways can we show a relation? One way is like in number 2, a set of ordered pairs. What's another way? What's another way?
Wait, for order pair?
For a relation. So we got ordered pairs. We can just write them as a list of ordered pairs, as a set of ordered pairs. Lindsay? A table. Okay, we can make a table. What's another way? Eddie? A graph. And what's the last way? There's a 4th way. What is it, Riley? What's that called? A mapping diagram. Whew, okay. So now that we know that there are 4 different ways that we can, represent a relation, let's now talk about that other thing that's going, well, we'll come back to, functions in a bit, but now that we got, we kind of have a feeling for relations, what's a domain then? Riley?
First coordinate.
The first coordinate, okay.
Set of
The set of first coordinates of a relation. And the first coordinate again is the what again? X values. So in other words, it sounds like if we want to write the domain of a relation, we need to make the set of all of the X values, all of the first coordinates of the ordered pairs. Well then what's the range? The Y values, the set of Y values are the second coordinate. Okay, well you know what, this domain and range thing is, you're going to have to get a handle on it. You're going to have to figure it out. Remember, you're learning now, finally your turn to, make sure that you're learning this. So you have those examples up there to study. We're just going to go right to practicing. Number 1. Here's a relation represented as what? A table, yeah. Duh. Okay, so now what is the domain of that relation represented as a table? Well, we're going to write domain out. And then we're going to make those, those little fancy curly Q set notation. Have fun. Okay. It's not a parenthesis, it's a curly, curvy, fancy bracket. And I kind of like to think of it like this. It's kind of like a C, and then another C, and coming out between those 2 C's is a sideways V. That's kind of what it is. It's like a C, and then a V on its side, and then another C. So get good at those, okay? So we got our first set bracket. What is the set, the domain? Now, one thing that we're going to do is we're going to always give our domain and our range in numerical order from least to greatest. Not the order necessarily that they are given to us in the format they're given, but what are they from least to greatest? So what's the first member of our domain set? -2. Next one? -1. And 0 and 1. Are there any others? No. Okay. Hopefully you wrote a little smaller than I did, because I think I might run out of room here. The range is next. So our range is also written with those, set notation brackets. So what's our range going to be? Again, least to greatest, not the order that they're given to us. And here's the other thing that we don't do. We don't repeat values. So if there's a range or a domain value that's used more than once, we only state it one time in our set. So how many members is our range going to have, first of all? 3. And what's it going to start at? 0. And what's it going to be next? What's going to be next? 1 and 4. You got this. Okay, you go ahead and do number 2 now, the one that was our ordered pairs example. Both domain and range with wonderful set notation, least to greatest, no repeats. And the domain is what, Austin?
-5, -2, and 4.
Okay, good job. Range is what, Chase?
I'm not done yet.
Oh, okay. Hayden? You don't know. Okay, Elizabeth?
4, 6, 12.
4, 6, 12, do we agree?
I meant 5.
You meant 5, that's what I thought. 5, 6, 12. The Y values, oh, there's, mine's kind of hiding underneath my thing there. Okay. 5, 6, and 12 are our range values. Okay. Okay, I'm thinking that you're looking like you want to move on to 3 and 4 because you got this. Okay, do it. Go ahead and do 3 and 4 now. If you have a, a concern or a question, get your hand up and I'll come guide you. And make sure that those set brackets don't look like parentheses, okay? Okay, volunteer for the domain for number 3. Monica.
0, 1, 2, 3.
Okay, thank you. 0, 1, 2, 3. Range for number 3. Haley.
5, 6, 7,
5, 6, 7, 8. Good job, ladies. Again, put in the order that they are from least to greatest, not necessarily the order that they're in the format, the type of way that they're showing the relation. Okay, number 4, the domain is Lindsay.
-3, -4, -5.
Okay, least to greatest.
-5, -4, -3.
Okay, -5, -4, -3. And the range is, Colin, I know you want to give it.
10, 11, 12, and 13.
10, 11, 12, and 13. Okay, good job. Okay, so any questions about how do we state the domain and the range? Now, these 4 relations, if we actually graphed them, could you tell me, would they be continuous or would they be discrete? What do you think? Do you think this is a discrete situation or do you think this is a continuous? What's discrete mean again? Dots, like separate points, right? They're not connected. Okay, how about continuous?
Straight line.
They are connected. It can be a straight line, it can be a curve, it can be, whatever. It doesn't have to be necessarily a line, but they are connected. There's a continuum going on. Okay, well notice what we were able to do with all of these. They are all discrete. We were able to list individual members of the domain and individual members of the range. Tell me something about number 5. Do you think that looks like a discrete graph? That's continuous, isn't it? Okay, here's the deal. When we have a continuous graph, do you think there's going to be any way we could list every member of the domain individually? How about the range? Why not? Why not? Why can't we list every one of them individually? What's the problem? Don't you know your numbers? It what? It doesn't end? Well, it looks like number 5 ends. It's a line segment, so it ends. It doesn't have any arrows at the end, so it's, stop. So can we list every member of the domain and maybe every member of the range since it's a line segment that doesn't go on forever? Really? Tell me how many numbers are there between 1 and 2?
0. Or like
0.
fractions.
Oh, so fractions aren't numbers.
Oh, they're not?
They are. I thought you were saying they weren't.
Oh, yeah, they are.
They are. So there's a ton of fractions between 1 and 2, right? Like 1 and 1,000,000. And there's a ton of decimal names that are also have, fractions have decimal names. So can we list every number between 1 and 2?
No.
It is not possible. There are an infinite number of numbers just between the two integers 1 and 2. So we can't begin to list them all. So when we have a continuous graph, we're going to use a compound inequality, which should sound familiar. It should sound familiar. In fact, we're going to use the compound and inequality. So the domain for this one and the range for this one both have to be written as compound and inequalities, showing between what two values, since we can't list them all, between what two values can we identify the x values. So it's kind of nice if we know the ordered pair names for the ends of this, right? What's the ordered pair name for this point right here? -2, 1. Remember, this is its x value, this is its y value. Remember, that's how it goes. What's the other one's ordered pair name at the other end? 2, 4. Okay, everybody verify. Look at your graphs. I can't tell very well on my smartboard. The lines didn't come up very well. So, can you?
Yeah.
Do we have good choices? Good names for our ordered pairs? Okay, and again, remember, this is an x and this is a y ordered pair, right? Okay. Well, then the domain, remember, is all of the x values, right? So what do you think the domain would be? From -2 to +2, yeah. In other words, from right here to right here, that line segment covers, so we have a -2, and since we have a closed point at the end, does that mean -2 is included? Yeah. Didn't we just do some shading and number lines for inequalities? Shaded meant include me. Open means leave me out, right? Are there any open endpoints here?
No.
Okay, so -2 is less than or equal to x is less than or equal to +2. Two different kinds of 2's here. Nice. So in other words, remember, compound inequalities, it has to fall somewhere in between those two. And if you put the equal to bar, that means they're inclusive. They get to be included. Okay, you write the range now. What's the range of this one? It's a compound inequality. What's the range made of x values or y values?
Why?
Oh, y's. Don't use x's in it then. Okay, who's got the range for us? Go.
One is
I want to hear it as a compound inequality.
one is less than x or y and less than 4. If I said that right. It's less than or equal to.
Okay, so what do you want? You want the equal to bar in there?
Yeah.
Okay. So now do I have it the way you want it?
Yeah.
Okay. Anybody agree with Monica? Yeah, you should. Because the smallest y value is right here at 1. The highest y value is right there at 4. So it's in between those two values, inclusive of those two values. Okay, you got it. Now do number 6. All yours. So, again, you have to list it as a compound inequality when it's a continuous graph. Is this a continuous graph? Number 6. Is it continuous? Is it connected?
Yeah.
Yeah. It's continuous. What would be useful to do in this one?
Find the order pairs.
Find the ordered pairs at the what? Which ordered pairs? At the corners, yeah. It'd be good to get the corners ordered pair names, right? Wouldn't that be kind of useful? Okay, who's got the domain for us? Who's got the domain? Go! Austin.
-3 is less than x, and x is less than or equal to both of them.
2, was it? Okay. Do you guys agree? You should. Because look at right here. It doesn't go any further than -3 on the x-axis. It doesn't go any further than +2 on the x-axis. Yep, we got it. Okay, how about the range? How about the range? Volunteer for the range. Can't be Austin, can't be anybody else who's already spoken. Tate, you got this.
1 less than or equal to y, 3 greater than or equal to y, or y less than or equal to 3.
Thank you. Yeah. That's how we write compound and inequalities. They're not separated out. We don't see the word and. It's all one statement. And do you guys agree with that? Because the lowest y value is 1 and the highest y value is 3?
Yeah.
Do we agree? Okay. This is the part that trips up students the most, being able to identify domain and range from a continuous graph. You got the being able to pull numbers out of tables and ordered pairs and mapping diagrams. It's, this other stuff. These continuous graphs, that's where we get, hung up. Okay, let's go to the back side next, okay? Anybody have any questions, though, none that are unanswered here from the front? Some of you are wishing right now you'd watch the video tutorials, aren't you? Okay. What's a function then? What's so great about a function? How do I, get to claim that a relation is a function? Is every relation a function, do you think? No. Not every relation is a function. Not every one of your relatives is, on your like list, right? Some of them are. Every relation is not a function, but what relations are functions? The ones that buy you good Christmas presents? Lindsay.
Once the domain has its own range value.
Yeah. When you're looking at the relation, if each domain value has exactly only one range value, it gets to say, I'm a function. I'm special. I'm above the rest of you. Okay, so we have to decide when do we have functions. Now, I'm going to, again, leave those examples for you to study on your own, and we're going to just go practice here. Number 7. What do you think? Do you think that relation is a function? What are you feeling about it? We got x equals -2, we got and then we got a y1. When x is equal to -3, it says the range value for that one is 2, and then when we have x equal to -3, the range value for that one is 3, and when we have x equal to -4, the range value for that one is 4. Is this a function? All in favor of, let's name this one a function. So the rest of you are opposed? Okay, convince us why. Chase, can you tell me why?
No.
Colin, can you tell me why? Can anybody tell me why? Eddie?
It's not a function because -3 is with 2 and 3.
Yeah. -3, the domain value of -3 has 2 different range values. Right here, let's just circle it in our table, right here. When we have -3 as our domain value, it has 2 different range values. So we're going to say is not a function. And we're going to explain, like they said, the domain value -3 has 2 different, and if they were the same, we'd say, well, it's just redundancy. But this one has 2 different range values, and we circled it in our table. We said, look at there. That x value of -3 has 2 different range values. So this is not a function. It's still a relation. It's just not a function. Okay, how about number 8? How do you feel about that one? Number 8. What's your feelings on that? We gotta make a decision here, come on.
Yeah.
All in favor of it is a function, raise your hand. All opposed to it being a function. The rest of you want to give it a new name. What do you want to call it? Well, some people wanted function, some said not a function, and the rest of you didn't raise your hand, so that means you have a different name for it. It's a Lagrange. Okay. Is this a function? Okay, convince us why.
Because the domain doesn't have the same value for the same thing.
Okay. So if you,
Split it.
so I think she's trying to say each domain value has only one range value. Yeah. So 4, the domain value of 4, what's its range value? 5. The domain value of 8, what's its range value? 5. It's got its own though, doesn't it?
Yeah.
Right. How about 12? Does it have more than one range value? No. How about 16? Does it have more than one range value? No. So this is a function. Yeah. Is a function. Each domain value has only one range value. That's what we're looking for. Each domain value has only one range value, so you know what? Wins the prize of being a function. Okay. How about number 9? What do you think of that one? There's a continuous graph. Because it's continuous, does that just automatically say one thing or the other, do you think? Okay, we might not want to make that assumption yet. It's continuous, but what is it that we need to look for? We need to look for any x value having, say, only one range value. If it has more than one range value, what happens? It's not a function. So how do you feel about this one? You think it's a function?
Yes.
So every x value on that triangle, that's the graph, okay? Every x value on that triangle has exactly one range value. Are you still convinced? Every x value, every domain value has only one range value? Did I just disprove it? How many other times do you think we can disprove it? A whole bunch of times. You know what? There's a point right here that matches up with the point right below it. There's a point right here that matches up with the point right below it. There's a point right here that matches up with the point right below it. You know what? I could go on for a while. In fact, I could make it so that you wouldn't even be able to see my points anymore. Every x value between what and what has more than one y value. It actually has 2. Every domain value between what and what. Well, what is the domain of this? Maybe that's what we should write first of all. The domain is what? What's the domain of this one? Okay, well, I'll come over here and I'll, start doing some work for you. What's these guys on the ends here? What's the domain? One is less than or equal to, x is less than or equal to
3. Or no, 5.
5. Huh. Well, does domain value 1 have more than one point? More than 1. Is there a point on the triangle above or below it? Is there a point above or below this one? No. How about the 5? Is there a point above or below it? How about all those guys in between? Yeah. So we're going to say is not a function. every domain value between 1 and 5, oops, and spelled with the 5 at the end instead of a D, 1 and 5, every domain value between 1 and 5, has 2 different range values. This is huge. You have to have an understanding of this, okay? You can't just be like, I'm so sick of this. What I tell me right now, you gotta know it. Anybody have questions? You might even want to watch the video tutorials also. Maybe you'll find out that those guys are, computer or something. Okay. So let's go back to our last page then. Well, the good news is here that they started to draw our formats for us, so it'll take us less time. Because we're to express each relation as a table, as a graph, and as a mapping diagram. Now, when we do that in the table, here's what we do in the table. We go from least to greatest with the x values, but we have to put the corresponding y value with it. We can't change up the order of the y's, okay? So in the table, we would start with -2, and then we put our -1, but we'd skip over that 3, and we'd go to that other -1, and then we'd do our 3's. And then we'd say, now, what's the corresponding y values for each of those? Now order does not matter. Relationship matters. Which one belongs with which one? So we need a 5 to go with the -2. We need a 1 to go with one of our negative ones. We need a -2 to go with our other -1. And we need a 1 to go with our 3's. This is a discrete graph, so go ahead and graph those 4 ordered pairs. Put those 4 points on your graph. Do not connect the dots. This is not play connect the dots time. Graph those 4 ordered pairs, that relation. And if you did not in your SQ3R get yourself reacquainted with graphing, this is going to be painful. Okay, I want you to think of a mapping diagram as a domain and as a range, okay? So would you just, like maybe put that above here. This is going to be our domain, this is going to be our range. When we map, that's how we map. We put them in, it's like you're putting the domain together and you're saying least to greatest of the x values, least to greatest of the y values. So this would go -2, -1, what else? No, not -1 again. Remember, no redundancy in the domain. And 3, yeah. And how about the y values? How would they go?
5.
No, least to greatest. -2,
1,
1,
5.
5. Okay, now we map. Now we have 4 arrows to be drawn here, right? When we have -2, it maps to 5. -1 happens to map to a couple of members in the range. It maps to this guy and it maps to that guy. And 3 maps to 1. So it's kind of messy. Our mapping diagrams are always very neat looking, like they tend to be sometimes in those wonderful example problems in the book. Okay, you go ahead and do number 2 now. You got this. And you better be quick. We're running out of time. No copying from me, but if you want to, check your work after you're done with something, you can. you feeling about this one? Do you think this has a function?
Yeah,
Why?
so each domain has a range.
Each domain has only one range value, doesn't it? Okay, anybody have questions about that one? Pretty easy to do? Yeah? Okay, remember our mapping diagram kind of looks like we're setting up a domain and a range, and so that's where our order matters for, okay? Last one. Give the domain a range of each relation, tell whether the relation is a function, explain. Number 3 is a what? Discrete graph or continuous? Continuous, that means our domain and range are going to be given as compound inequalities, yeah. So the domain of this one, well, it would be kind of nice if we would say, you know what, the endpoints are 0, 0, and what's the other endpoint? 4, 4, okay? And, you know, they don't really have the points drawn there, but we can put them there. The line goes to it, so we're going to say they're included. So now our domain then would be, yell it out for me.
0 is less than or equal to x and less than or equal to 4.
You got these curly cues down yet?
No.
And the ranges. Oh, where's the range? Why? That's where you're going to mess up, yeah. Yeah, they just both happen to have the same endpoints. They both have the same endpoints, but don't forget domain is x's, range is y's. So in other words, it went from here to here on the x-axis. That's what helped us get our domain. It went from here to here on the y-axis. That's what helped us get our range. Okay, is it a function?
Yeah.
Okay, why?
Because each domain has its own.
Only one? Each x value on that line, every x value on that line has only one range value. So we would say is, it is a function, each domain value has only one range value. They each have their own range value and only one range value. Okay, number 4. What's the domain? It's a mapping diagram. Come on, what's the domain? This is easy. 8 and 9, yeah. What's the range? Oh, those stinkers, they didn't do it in the way I like it. What's the range? -9, -6, -4, -3. Is this a function?
No.
What? Why not?
Yes, because the domain doesn't have one range.
Both of those domain values have 2 different range values, don't they? This is not. Each domain value has 2 different, and the word difference is kind of important in there, 2 different range values. Okay, and I'm going to leave that last one for you to do on your own, because I know you got this. Okay? Because now what you need to do is you got to make a decision. If you're going to do the vocabulary assignment, you need to head to that back table where Caitlin is sitting, and she'll stay out of your way, I'm sure. If you're going to do the vocabulary assignment, you need to pick up the vocabulary sheet. There is not a rubric this time. Just grab the vocabulary sheet. You're only doing the lesson 3.2 terms, which is 4 of them. That's all you have, is 4 of them. And then any supplies you might need, because you know maybe which way you're going to do it. Anybody have any questions?